Welcome to this eLearn Security of Video training lesson on HPing. In this video, we will see the basic scanning techniques using HPing. HPing is a popular TCP IP packet assembler and analyzer, and it can be used for many different purposes such as port scanning, firewall testing, OS fingerprinting, and much more. The first thing we have to do in order to understand the basic usage of HPing is to have a look at its manual. We can open a terminal and execute hping3-h to list all the available options. As we see, HPing has several options available. We already covered some of these options in the host discovery phase. We will now focus on port scanning techniques. The very first technique that we're going to see is very popular and stealthy. We're talking about the SYN scan. SYN scan is also known as half-open scan because it does not complete a full TCP connection. It works in 3 steps. First, we send a SYN flag to the target machine. Then we wait for SYN ACK. And we terminate the connection. Please note that the connection is being terminated by the OS and not by HPing itself, due to the unexpected SYN ACK packet received. The benefits of this scan are its speed and the level of stealth it provides. Now that we all know how it works, let us see the HPing command. To run a SYN scan, we have to specify the -S argument. This will add the SYN flag on our TCP packet. By default, if no port is specified in the command, HPing sends packets to port 0. Most likely, we will not receive an answer from this port, so we have to specify a different port with the -P argument. One of the most common open ports is port 80. This is the port that we will use in this example. Moreover, since HPing keeps sending packets until we stop it, we will use the -C option to set a fixed number of packets to send. For our tests, let us set this to 3. Finally, we specify our target IP address at the end of our command. Before running the command, let's open Wireshark and add the required filters. We want to filter all the packets sent and received to and from a specific IP address. To do this, we will simply use the IPADDR filter followed by the target IP address. Now that Wireshark is configured, let us go back into the terminal and execute the command. Let's quickly recap the command. We will send 3 TCP SYN packets to port 80 to the IP address 192.168.1.1. As we can see in the HPing output, the responses we receive have the SA flag set. This indicates a SYN ACK response. In other words, the target port is open and listening. By having a look at the traffic intercepted by Wireshark, we can see 3 packets for each communication sent by HPing. The first one is the SYN packet sent by HPing. The second is sent by the target machine to our box and has the SYN ACK flag set. The last one is the RST flag sent by our kernel to the target machine, which terminates the connection. This is the default behavior of a SYN scan on a single port. But as you can imagine, we may want to specify a range of ports instead of a single one. To do this, we can use the same command as before, but instead of specifying a single port with the -P option, we will use the --scan argument, which indicates a scanning operation. When we use this option, we also need to provide the list of ports we want to scan. There are different ways to do this. We can specify a port range by separating the starting port and the end port with a dash. In this case, we will scan all the ports from 1 to 1000. Another way to specify ports is by separating each port we want to scan with a comma. For example, in this case we instruct HPing to scan port 80, 139, and 445. The last way we have to specify ports to scan is by using some special words offered by HPing. We can use the word all to instruct HPing to scan all the ports from 0 to 65,535. On the other side, we can use the word known to include all the ports listed in ETC services. Notice that these 3 methods can be combined together. We just need to separate them with a comma. For example, With this command, we are telling hping to scan ports 80, 445, and then all the ports between 500 and 550. Moreover, if we don't want to scan a specific port or a range of ports defined in the command, we can use the exclamation sign to negate it. For example, if we don't want to scan port 525 from the previous command, we will add the following option. But be aware that when using the negation sign, you have to enclose ports between quotes. Otherwise, your shell will interpret the exclamation mark. Now that we know how to specify ports, let us run our scan against all the ports from 1 to 1000. Before starting the scan, let us go back to Wireshark and change the current filter. The filter we're going to use will show only the SYN-ACK replies from the target machine. We do this in order to avoid displaying all the SYN packets sent by hping and all the RST packets sent by closed ports. Let us now go back in the terminal, change the port range, and run the scan. As we can see, the output contains a table that shows all the listing ports and the flags set, which in this case are SYN and ACK. At the end of the table, all the non-listening ports will be printed. From Wireshark, we can see the ports that replied with SYN-ACK. We can check the port in the info column, or by selecting the packet and inspecting the TCP section at the bottom. So as displayed in our terminal, port 80, 53, and 21 are open. Another very popular port scan method used is the UDP scan. As a UDP scan is generally slower than TCP, network administrators tend to ignore the ports that run UDP services. Popular services relying on UDP are DNS, SNMP, and DHCP. In order to execute a UDP scan with hping, we can use the command we just saw. But we have to change the -S with the -2 option or --UDP. Once again, we will scan ports from 1 to 1000 by using the ---- scan. As we can see, we don't get any response. Only in the case where a UDP packet is received, the port is indicated as open. ICMP errors packets indicate the port as closed or filtered. Another popular scan that one can use to avoid certain firewalls is the Christmas scan. The Christmas scan is a combination of the FIN, URG, and PSH flags. Depending on the responses, we can detect if a port is open or closed. To execute a Christmas scan with hping, we can manually set the required flags by adding the -F, -P, and -U arguments to our command. Notice that instead of setting the flags separately, we can also set them with -F, P, and U without spaces between them. Now, depending on the results obtained, we can infer different port status. Before running the scan, let us clear the old Wireshark session. In our case, we got the reset and acknowledge flags, which indicates that the port is probably closed. As we can see here in Wireshark, since we did not specify any specific port, hping will send the packets to port 0. What's worth mentioning here is that if we specify an open port, like port 80, we will not receive a response. If so, it might mean that the port is open or filtered. Let us change the port in our command, clear the Wireshark session, and see what we obtain. As we can see, our machine is sending out the packets, but the target machine is not sending back any packet. Indeed, if we go back to the hping results, we can see that we did not receive any response. Thanks to this behavior, we can say that the port 80 is open. In order to understand this better, let us try to run the Christmas scan we just ran, but this time, let us define a port range from 1 to 100. We can see the replies by specifying the -V command. This will enable the verbose mode and will list all the responses. If we inspect the results, we can say that the non-responding ports might be open or filtered. while the responding ports might be considered closed. Here, for example, we can see that the port 80 is not listed, since it did not respond to our packet. Moreover, at the end of the output, we can see all the ports that behave in the same way, which in our case are 21, 53, and port 80. Similar to the Christmas scan, a null scan may also be used. Here, no extra option is needed to be specified. As most systems won't rely back on such packets, its purpose is to check for ports that do not reply with RA flags. Null scan is just a TCP packet without any flag specified. In our case, we can see that ports 21, 53, and 80 are not responding to our requests, which means that they might be open or filtered. Notice that hping allows us to configure almost everything in our packets. If we print the help manual, we can see that we can set the TCP sequence number, the TCP ACK, and all the other flags such as FIN, SYN, RST, and so on. We just need to specify them in the command. As we can see, hping provides many configurations to use. The way it allows us to craft and manage the packets is what makes it so useful. On every penetration testing scanning phase, we highly recommend you use it. Thanks very much for joining us.